right, hello everybody. Good morning. My name is Savita Banerjee. I'm Vice Tech Chair. We have our illustrious Program Chair finding his way into the room. He'll be back. So welcome to the second day of ITC. Thanks for being here. We know we're competing with Disneyland, so we really do appreciate your business. But you guys have your priorities straight, though, in all honesty. After all, DFT is all about doing fun things. And who doesn't feel like a kid in a candy store soaking in all this cool technological innovations in our community? Yesterday we had a packed day filled with all these innovations in 3D ICs, memory trends, new standards, EDA solutions, and the test community has so much more to offer, from the grand challenges that Anne presented to us on Monday, and we have so many more design complexities to address. And everything, pretty much if you build it, you've got to test it. So we're going to stay in business for quite some time. So today is AI Day. I'm super excited about that. In addition to the keynote that we'll get to soon, there are AI sessions about functional safety of AI in EDA, and we also have a special session on the Metaverse test challenges. We've got the PhD competition today, so let's go support the next generation of engineers. We also have another visionary talk this afternoon, right after lunch, about automotive trends delivered by Dipti Vachani from ARM. And that's going to happen right here, again, after lunch. And then the event that I want our entire community to be present for is the DEI panel. And honestly, if you don't know what DEI is, come join us for that session and join the conversation. All right, before we get started, let's give it up for the sponsors and the volunteers who've kind of been working behind the scenes to make all this happen. All right, thank you. And now for today's very special keynote. AI is ubiquitous at Meta in all the services and products that we offer. But how is our social technology driving a new wave of innovation and disrupting the compute paradigm? Well, I am thrilled to welcome my two MetaMates to share our vision of the metaverse and the key enabling technologies. They will describe what we're already able to achieve, where we need to go, and what support we need from all of you, our ecosystem partners, to help us get there faster. So we're basically going to try something different today. We'll start with their presentations and then follow it up with a fireside chat. So Caitlin Kalinowski is going to talk about AR glasses and delivering the metaverse vision, followed by Manohar Paluri, who's going to talk about progress in Gen AI. So Caitlin Kalinowski leads the AR hardware team in Reality Labs at Meta. For the past 7 years, she led VR hardware, the division responsible for the Meta Quest 2 and touch controllers, as well as the Oculus Rift. Before working at Oculus, Caitlin was a technical lead at Apple on the Mac Pro and MacBook Air products, and was part of the original unibody MacBook Pro team. She received her bachelor's in mechanical engineering from Stanford University, and she's passionate about increasing the number of women and other underrepresented minorities in the fields of technology and design. She believes that the next generation of products must be designed and engineered by people with different backgrounds and experiences to create the best product experiences. Manohar Paluri is a senior director at Meta and leads an organization focusing on Gen AI. His team is at the intersection of research and product and powers image and video understanding capabilities for hundreds of products across all of Meta's family of apps, which serves billions of people every day. Prior to his current role, Mano led an organization focusing on perception and robotics efforts in AI. His interests lie in pushing the frontiers of computer vision, conversational AI, and multimodal reasoning. He received his master's from Georgia Tech and worked at Google Research, IBM Watson, and Sarnoff Corporation. With that, please join me in welcoming Caitlin Kalinowski to the stage.
Thank you. Thank you. Good morning, everybody. I'm so happy to be here. Thanks for having me, and thanks to ITC for having me. I work on AR glasses hardware at Meta, and our mission is to recreate the future, to re-envision the way that people connect. And in the last 4 years, Reality Labs has seen incredible growth. In fact, this is a big week for us. We just had some products come out yesterday that you might have heard a little bit about. I'll talk about those in a second. So hopefully folks have had a chance to experience our devices. Has anybody here tried VR, tried the Quest, or tried our new Ray-Bans, just to get a sense? Okay, so about a quarter of folks, great. So I'm assuming that we're all operating with the same amount of knowledge about the objectives of the Reality Labs team. My aim for today is actually to bring us together and to talk about how we can create the future, because no one group or person is going to create the future of the metaverse. It's extraordinarily complex. It's going to take a huge number of people to get it right. And to get us there, I want to tell you a little bit more about exactly what we're building, discuss how hardware and software are intrinsically, it's a field where hardware and software co-design is so important. And there's very few places I've worked or projects I've worked on where it's as important as AR glasses and metaverse tech. And I want to explain how these technologies will ladder up to Meta's broader vision of building community and bringing the world closer together. So our goal is to move ahead with greater clarity here about where we're going and how we get there. And over the last half century or so, starting with mainframe computers, of course, we then had personal computers, we had laptops, we had mobile. I believe that AR and VR, immersive tech, plus advanced AI, which Mano's going to talk about a little more in his talk, plus advanced input technologies that don't actually exist yet, will create the technology core driving the next step, the next revolution in personal computing. Let's play a quick video we created for Connect in 2021.
Did you know the rings are made up of billions of icy particles?
Really?
All right, perfect.
Oh, hey, Mark.
Hey, everyone. Boz, is that you?
Of course it's me.
Like a shot.
Some call it skill.
Keep talking.
Yo.
You're here! Hey. Let's jump in. Hi.
Hey.
So what do we think?
I think it's ready.
Imagine you could also drop an exclusive product in the metaverse.
Let's go. Keep it going. Okay. So where are we coming from and where are we going? For a while we had text. I mean, I remember before we had cell phones, and then the first cell phones, we were communicating with text. And then we started to communicate with pictures. And I remember when I was in college, we really didn't have cameras on our phones or good cameras on our phones. Then suddenly we were in this video era. Well, the thing that's exciting to me about this new era is it's immersive. And there are things that you can do with being immersed in information that you can't do in any other paradigm. And the great thing about immersive experiences is you can be in them with somebody else, whether they're in the same location as you or they're in another location. And so these are the two things that I think are so exciting about the metaverse and the future of these products is you're going to be in embodied experiences, but you're going to be able to experience those with other people, whether they're there or not. And this is why I think augmented reality is so exciting. Now, last year, we came out with Ray-Ban Stories, and this was smart glasses, and they had one camera for video and one camera for stills. So we launched Ray-Ban Stories in 2021, and actually just yesterday, we announced the evolution of this product, which is Ray-Ban Smart Glasses. So if you haven't checked these out, the new product coming out, Ray-Ban Smart Glasses, both projects were done with EssilorLuxottica. So these kind of iconic Ray-Bans, and they don't really look like necessarily smart tech other than the LED that comes on when you're recording. And so the key features of this is you don't have to pull out your phone. You know, if you're doing something immersive in the real world, you can actually record it or take a picture by tapping on your glasses. This lets you stay present with your friends and your family and the world around you. And all this in this iconic design that'll let you feel like you have regular sunglasses. And this is an important step along the path to immersive internet. But of course, the holy grail of AR is full AR glasses. And what I mean by that is AR glasses that have binocular displays, that are high field of view, eventually that are all day wearable, where you have the ability to understand what's going on around you, and you have sensor fusion, you have custom silicon, and you're able to have a high field of view overlay on the world. So this is where we're headed. This is where we are today. So I love these. If you haven't checked them out, these are the ones that actually just, you could start getting them yesterday. The new ones, the Ray-Ban smart glasses, have this really cool charging case, and they're more powerful than last year's with 8 times more storage and Qualcomm Snapdragon AR Gen 1 platform. Of course, as Savita mentioned, I was doing VR for 7 years. And the Quest 3 also just came out yesterday. It was available yesterday, and we're really, really excited about that. And so in terms of what Reality Labs is building publicly, the closest connection today to the metaverse is what we're making in VR. Its magic power is it gives us a sense of presence, and it's really hard to explain if you haven't tried VR, but when you move your head around in VR, what you see changes, and it gives you this really embodied sense. And that has some pretty cool side effects. One thing is, if you're playing a video game or if you're in a location, it feels real to you. And like I'm a gamer, I like video games. And if somebody's shooting at you, you know, on a 2D screen, it's one thing. But if you're in an embodied space and some robot's shooting at you, it feels scary. You know, you get this like adrenaline spike. It's really interesting how our bodies and minds respond to immersion. We're scaling the VR ecosystem. VR is getting more social. This is a thing, you know, in early VR, you'd play a game kind of on your own, and it was really cool. But now we're getting into these social gaming experiences where you're playing with other people. Also, VR fitness was actually surprised us. VR fitness is a huge vertical and something that really popped in COVID, but has staying power where people actually, you know, there's this really great boxing game actually where you can really feel it's actually exciting. It's much more fun, at least for me, than going to the gym. So people have spent more than $1.5 billion on Quest Store content, more than 120 titles. Actually, Assassin's Creed is coming out in VR next month. I'm really excited about that one. We also last year had a strong holiday season. The Oculus app was the #1 app on the App Store on Christmas Day. The other exciting thing is these products are beginning to incorporate AI and coming from within the company, a trend I expect will just continue to accelerate as our AI gets better and better. So we need to define the metaverse. This is tricky, but it's basically a set of digital spaces, including real life 3D experiences that are connected to each other. So you can easily move from one to the other. And the metaverse allows you to do things that you can't do in real life with people who aren't physically with you. I know it sounds like a lot of words. We're going to dive into what that actually means. But what I think is you're going to see this as an evolution of social technology. The same technology that allows us to talk, correspond, see each other is evolving. And over the last decade, as we move from a desktop to mobile web to internet that's everywhere, this next phase should make you feel like you're really there with the people that you want to be experiencing either work or games or other really important experiences to you. Or if you want to be somewhere and you can't be there, the metaverse can help you feel like you really are. All right, what are our principles when we build this stuff? Our principles at Meta are, we don't want to surprise anybody. We want to be transparent about how our products work and the data they collect. We want to provide controls, so you're in charge of your experience. We want to consider everyone, and we want to put people first. So what for this group, basically? Well, if you think about the metaverse as a pyramid, the enabling technology, and that obviously working well, is the base of the pyramid of what's going to build the metaverse. And what my team's working on is enabling devices to build on top of that base. And then finally, the metaverse is essentially software that's going to run on those devices. But this enabling technology is non-trivial. It is a lot of technology that's not been developed yet that we need to develop, from silicon, a lot of custom silicon, multiple custom silicon chips per device. Of course, display and optics need to be great. Electromyography, or EMG, as an input technology, machine learning, computer vision, graphics, wireless, and of course, AI and Gen AI, I think is going to be a big part of the future. So all of this needs to work to make this dream a reality. And I want to just talk a little bit about what does it do? What is AR? What is full AR glasses? What are they going to do? Let's disambiguate this. So we all kind of live in the real world, at least most of the time. I'm not sure. This looks like a little generated, but let's pretend this is the real world. And then you've got VR. And VR really, I think its superpower is immersion, which means really bringing you to a place where you aren't, right? Bringing you to a fantastical world on, like, if you want to go travel to the Grand Canyon, whatever it might be, that's what VR is good at. Now, augmented reality is a little different. Unlike VR, where the world is shut off, yes, you can have pass-through cameras and videos so you can see the real world around you, but it's not real photons, right? It's a reprojection. In AR, you're seeing the real world. And in AR, really good AR, which we don't obviously have yet, will be able to understand the context around you and show you what you care about in real time. And maybe your AR glasses are off most of the time, but let's say you wanted to go to Disneyland today and you don't want to pull your phone out every 2 seconds. You just wanted to find out how to get to the Rise of the Resistance. A really good AR glasses product would actually say, oh, it's this way. Overlay on what you're seeing. It would have world locking. It would be able to show you an arrow of where you're going. It would be able to let you sign up for the next ride. It would let you, communicate privately with your family. I mean, this is something that I believe we're going to have once a lot of this base work is done. And so what is this going to look like? How do we know we get there? Well, consider the glasses a lot of you are wearing. They enhance the acuity of your vision, right? But what if they enhanced perception in other ways? What if they gave you what we might call superpowers? It's been predicted that instead of carrying smartphones everywhere, many of us are going to wear stylish glasses instead, AR glasses. We think that we're going to be wearing those most of the day and using them in most aspects of our life. And if we're right, that means that the real and virtual worlds are going to have to just mix and match together intuitively. It will feel intuitive throughout the day. And what kinds of things do we imagine? So there's a big list, but I'm just going to talk about a couple of them. What if my glasses could enable me to see in low light, or possibly in light bandwidths that I can't see in at all, right? I'm on the road late at night, a deer comes across, maybe I have the ability to pop out an infrared overlay onto that in my glasses. That could be really cool, I think. What if I could see people or places on the other side of the world in real time that are really happening? What if, you have vision loss and it's not really correctable? Of course, we got a fixed focal length, or we will for a little while. We do in VR, we will for a little while. What if my glasses could enhance acuity in different ways, so I could read things that even RX prescriptions couldn't allow me to read? What if I couldn't see at all, and I had really good AR glasses that had good cameras, and when I got my mail every day, I could just lift it up in front of my face and have my glasses read back to me who I got that piece of mail from? I mean, this actually is one of the things I'm most excited about, is how are we going to support people who may need additional augmentation of their senses. So let's just use a hypothetical example. Let's say I want to go to a market in a country I don't know, and I want to know what the heck I'm looking at in this market, right? I want to have labels over, maybe some of the things I'm seeing and figure out what contextual information I'm missing because I'm not from that culture, or I'm not from that place. What kind of technology do these AR glasses have to do for this simple task of labeling or showing you what movie's coming up as you walk by a movie theater? All right, so first, optics and displays, that's obvious. You need a high field of view display, high brightness. This is non-trivial, right? High brightness in daylight is quite tough. You need eye tracking. You need to know what you're looking at. You need computer vision, certainly. You need graphics. You need to be able to drive this rendering that you've got. You need audio. You might need audio context. You might actually be able to hear what's going on. Of course, you're going to have probably subtitles, right, from the real world. Maybe you can't hear very well, or maybe somebody's speaking a different language. Wouldn't it be cool to have subtitles on if you go traveling and you could just see what people are saying? Eventually, I think it could be really cool to auto-translate what you want to say in the audio of the glasses. So this is stuff that we could do if we have the right technology. And then, of course, you need this contextual awareness that comes from sensor fusion, good sensor fusion. You need world locking, right? You want this label to stay with the thing it's labeling. Also pretty tough. You need really good SLAM cameras. You need good computer vision there. And finally, you need depth sensing. You want these labels to be at the right depth. So this simple sounding thing, I want to label something, I want to see what movie's coming, requires all of this technology that I know all of you are working on, probably different aspects in different products. And you can imagine all this coming together. In addition to all that, we need low friction input. Right? Right now, if you're typing on your phone, that is a pretty latent way to communicate. It takes longer than it probably should. Your brain's working a lot faster than you can type out on your phone. So how do we do input in this new technology? And how do you do private input? We actually don't know. So we got to invent this. We got to figure this out. Second, using contextualized AI, you want to build a personal interface that's unique to you. Like what I need as a speaker on the stage, I need contextual information that's different than what you need in the audience, right? We have different needs. If our glasses can understand where we are and what role we're playing in whatever community we're in or whatever we're in, that could really give us a better experience. All right, I'm going to speed up a little bit. But basically, in addition to all of this, what my team's working on is hardware integration. This all has to be in a package that's actually wearable, that's actually good looking, that actually works, that someday can be on all day. Non-trivial. Everything needs to be in this glasses form factor. It needs to be socially acceptable, right? Lightweight. This is a highly thermally constrained product. The heat flux is non-trivial. So every single sensor, we have to have sensor fusion to minimize the number of sensors, but every single sensor actually has to be as power sipping as possible to give us someday all day battery life. So all this poses significant challenges, requires innovations in almost every area, from material science to reducing sensor sizes, hand and body tracking, computer vision, et cetera. Of course, AI plays a critical role and has a profound impact on all elements of an AR glasses. And when we think about AI as something that consumers are going to interact with, and of course that's true, AI is going to have to be predictive and understand what information you might want and when to show it and when not to. But AI is also important to take the data we're getting from sensors, denoise it, and make sense of it. So we think all kinds of different AI are going to be critical here. Now, on AR glasses, there's a variety of sensors. I'm trying to go back here. There we go. There's a variety of sensors, and even today we've got cameras, of course, we've got audio technology. You need really good microphones, you need noise canceling, and you need sensor fusion to kind of get to where we are today. And then you're going to have real-time computer vision capability needs to make sure AR functions. That's semantic segmentation, depth estimation, object recognition, eye tracking, optical flow estimation, optical character recognition. That all relies on high quality imaging, of course, coming from the cameras and the sensors. And then You've got to get really good data in from those cameras. But unlike a DSLR, even mobile sensors are 1/20th of the size, and you need them even smaller for AR glasses, so it's another 9x smaller. So you need to get all this information from these tiny sensors, very noisy, low resolution. We actually think AI can help with that. You've got a small number of pixels, you've got noisy pixels. You should be able to use AI to help denoise this. So think about something really simple. You want to ask your glasses how the weather is at Disneyland because you want to go on some rides. A voice assistant is going to be really important. And if you haven't used these glasses, it's free state audio. So it's coming from here, but because it's very close to your ear, generally you hear it pretty well and the people near you don't hear it very well. They might be able to hear something, but it's basically free state audio that's private or mostly private. So imagine the user utters a phrase like this. It goes through the front end signal processing and audio enhancement to denoise. You could engineer it with a wake word to trigger the voice assistant. The automatic speech recognition module takes audio from the front end, generates transcription. Based on this transcription, the natural language understanding models give the intent and slot the information. Then the natural language generation module provides the system's response to the user's query, and text-to-speech can synthesize a human voice to answer. That's fairly complex. That's a lot of work to get just an answer to how is the weather in Disneyland. And besides the vision and audio tech, we built a whole set of technologies, and we're building these now. These are research projects to understand other signals to enable low-friction interaction. In fact, my colleague is working on the wristbands. Now, this is electromyography. So imagine in real life, if I put my thumb up, right? This is a public gesture. You can all see it. It's not private. EMG bands, we think, may be able to determine the signal from your wrist, from the EMG waves in your that is being sent from your brain waves, basically through your nerves. And instead of having big, gross movements, you may just be able to move your thumb just a little bit to navigate in AR privately, essentially. Now, this isn't, people get worried about like, oh, is this reading your thoughts? No, this is a public motion. This is something that everybody can see, but it's just gonna be something that you could make very small and could work in input. Obviously, this has to be proven. This is still research. Now, AI is super important. But we think AI needs to run as close to the device as possible and generally on device. As AR glasses take visual, audio, video, you want that to be private, and the best way we can do that is keep it on device. Network connectivity, of course, always comes in and out, as you guys know. You want your device to work always, so on-device AI is really important. So depending on whatever network environment you're in, it still works. And finally, on-device AI has better latency, but most important, better energy usage. It turns out that wireless trip from your glasses to the edge or wherever is actually very expensive in energy. And so this guy knows. And so like it's really actually very, very costly to have that round trip over the network. You want to keep it on device whenever possible. So I'm going to go through this quickly, but I want to use these slides to note that AI for AR is not trivial, and every use case kind of has different needs and different requirements, right? Think about audio and language related workloads. You need memory bandwidth and computational intensity. For AI-based depth, you need obviously more computation intensity. For eye tracking, you need usage frequency because your eye moves fairly quickly. And we have other applications like hand tracking and keyword spotting. And so not only do we need to optimize the system for one of these, we have to optimize the system for all of them. And so the truth is, this means our system needs 10 to 100x better energy efficiency compared to what exists now. But we don't know how to do that. We know how to do some of it. We definitely don't know how to do all of it. So this is like a huge, interesting area, I think, that's going to be a big part of making these all-day wearable and small enough. I'm going to skip this slide because we're going to run out of time. But the big point here is you have to do co-design. You don't have an even passable product without co-design. You've got to develop the silicon alongside the form factor, alongside the use cases, alongside the AI, alongside even the servers, I think, eventually. You have to do it all at once or it's not going to work, which means a lot of collaboration, a lot of companies working together to make this work. So finally, these are kind of some of the specific challenges we've got. We obviously, silicon's a big piece of it, right? You need to deliver this in a tiny form factor, more than even close of what we have now. And a thermal envelope we are constrained to. We need to use advanced tech nodes, balanced memory footprint with power. Of course, you're gonna need these chips to do 3D stacking, a baseline, and extend on-chip capacity with low energy access, high bandwidth, and low latency. And so I wanna close today with a video between Lex Friedman and Mark Zuckerberg. This is a podcast that came out last week. And it's pretty fascinating. What this is gonna show you what we call codec avatars. So you're gonna be, so basically how this works is Lex and Mark got scanned before this. They were hundreds of miles away. I think Lex was in Austin, Mark was in California. So they had their face scanned and then they popped on virtual reality glasses. And so I'm gonna show you a conversation that they're gonna be having. I know this is in VR. I'm gonna show you a conversation they're having in real time, hundreds of miles apart in VR, to give you a sense of what kind of sensor fusion, what kinds of compute, what kinds of network requirements are needed for the type of experiences I think eventually we wanna have on AR and that we can have, I think very soon on VR.
Where am I? Where are you, Mark? Where are we?
You're in Austin, right?
No, I mean this place.
Oh.
we're shrouded by darkness with ultra realistic face, and it just feels like we're in the same room. This is really the most incredible thing I've ever seen. And sorry to be in your personal space. I don't know how to describe it with words. It really feels like we're in the same room.
Yeah.
It feels like the future. This is truly, truly incredible. I just wanted to take it in. I'm still getting used to it. It's like, it's you. It's really you. But you're not here with me, right? You're there wearing a headset, and I'm wearing a headset. It's really, really incredible. Wow.
Yeah, we can put the light anywhere.
I don't know if people can see this, but this is incredible. The realism here is just incredible. I'm already forgetting that you're not real. Yeah, I'm curious to see if people could see that, like my heart is actually beating fast now. Like that such intimacy of conversation can be achieved remotely. There's been, I don't do remote podcasts for this reason. And this is like, breaks all of that. This feels like just an incredible transition to something else, to the different kind of communication. Breaks all barriers, like geographic, physical barriers. I hope that people like watching this can get a glimpse of like how incredible it is. It really feels like we're in the same room. Like there is that, I guess there's an uncanny valley that seems to have been crossed here. Like it looks like you, and it captures everything, like the flaws. Like to me, the subtleties of the human face, like even the flaws, that's all amazing. It makes you, it makes it so much more immersive. It makes you realize that like perfection isn't the thing that leads to immersion. It's like the little subtle flaws, like freckles and like variations in color, and it's fundamentally a new experience. Like for me to have this kind of conversations with loved ones, it would just change everything.
So you can see this whole video on Lex's podcast or on YouTube if you want. And so I just wanted to say thanks again. ITC, thanks for having me. Thanks for letting me come talk about what we're doing now and also where we think the future might be going. And I'm going to hand it off to Mano to talk about AI. Thank you.
Thank you, Caitlin. Morning, everyone. I'm always blown away by that video that we just saw. I come from India, physical distance from family and friends. So Meta always gave me a glimpse of using technology to connect people and bring the physical world closer. So all the things that Caitlin touched on is our vision and our push to technology to get there. And part of that is actually leveraging AI, which is my background. Don't know if the slides are projected. Awesome. So I lead the Generative AI organization in Meta. we are focused on building the frontier foundation models across various modalities: text, image, video, audio, speech, 3D. And you have seen an inflection in what these models are capable of. And this inflection comes from a lot of work that is happening across the board in the full vertical stack, all the way from hardware, scaling the data, scaling the machine learning recipes, thinking about various use cases that you can deploy, having users use it, give feedback, and use that feedback to align the models so these models become more and more capable over time. And that's what excites me, and we are at the cusp of it, and I can sense the technological shift happening, not in one product or in one modality, but across all of this because of a few of these changes, whether it's transformers, whether it's architectures in hardware, and so on and so forth. So today, I'm not going to talk about mixed reality. I think Caitlin did an amazing job covering what we are doing there. Smart glasses, these two are our hardware visions in terms of bringing the AI technologies as well as bringing in presence, physical and digital together. But I'm going to talk about AI, which is something that I work on every day. For mixed reality, there's a lot of AI models that are coming together already. And what we have with Quest 3 specifically is blending the digital and the physical world seamlessly. And that really requires fundamental models that actually represent the world, the physical world. Fundamental models in understanding audio, understanding text. So this is really, really exciting. And this got released yesterday. I'm hoping that we'll get a ton of feedback as people try mixed reality. Smart glasses, we announced at Connect, actually leverages our AI models, the Meta AI assistant that we built. So instead of taking out your phone and asking for information, the information is at your fingertips. You ask for it, you get it in a private way, and it's really, really accessible. So bringing a lot of this information at ease using, again, AI models and state-of-the-art hardware. So what you're seeing here is images generated using our foundation models. On the left is Llama, which has become a pretty common name now. Honestly, when we named the foundation model, we were thinking whether it is going to get popular, but the community has definitely embraced it. And I'm going to talk a little bit about our Llama model. On the right is what we just announced 2 weeks ago, EMU, Expressive Media Universe, our image generation foundation model. Both of these images are generated by EMU. It's confusing, llamas and emus. But the journey of Llama is fascinating to me because of the pace. It's hard to believe that just in February, we actually launched our first model of Llama. And that was a 70 billion model. That was a pre-trained model that can take text and produce text back based on a conversation you're having, asking for questions like an assistant, thinking about chatbots, thinking about entertainment, creative writing, helping you with things around coding, and so on and so forth. Since then, we open sourced Llama 2, which was in July, and we have a crazy amount of reception because what we did was understand from Llama 1 what the community wanted, what the developers wanted. So with Llama 2, we gave both the pre-trained models and the aligned models at different scales, the 7 billion model, the 13 billion model, and the 70 billion model. And then we doubled down on one of the use cases for developers with Code Llama. So this was the fast-paced acceleration. But one question that I always get asked is, why did you guys open source Llama? The other folks are not open sourcing their foundation models. And this gets at the core of our mission in terms of how we develop these cutting-edge technologies, whether it's hardware or software or AI. We want to learn through iteration. We want to learn with the community. We want to build models that are safer. And the more people building on it, more people hammering at it, red teaming it, using it for various use cases, makes this model safer. And eventually, you get this extremely great synergy of moving faster and building better experiences for many people. And anything that we have done at Meta touches billions of people because of our reach. And that's why these foundation models, when we open source them and when everybody in the ecosystem are actually embracing them, it helps us bring the best product experiences to billions of people. And the journey has just begun. And over the last 2 months, we have had millions of requests to download the model every day. We have had crazy amount of ecosystem that got developed over Llama, including the tools that were built, including some of the hardware changes that people are making on top of these architectures, including the community of thousands of developers helping each other, and how the enterprise community has embraced it. And this is, when I look at the stack, it's coming from the core silicon at hardware level, where people are looking at these foundation models and specifically the smaller models and what we can do on the hardware side, all the way to the top of the platform and the cloud partners that are actually making these APIs available and these models available for people to play with to build product experiences that we alone cannot build. This is really, really accelerating the development of product experiences on top of these foundation models. I'm super excited about it. And this is not just one company or one kind of a partner. It's across enterprise, academia, researchers across universities using it, and developers building tools on top of it. So this is really exciting. This is really positive. And if you look at the development of how these models are used for real-world applications like a conversational assistant, you have innovation happening at pre-training, you have innovation happening at fine-tuning, you have innovation happening at how people are actually using it and giving feedback across all of these types of developers. So I'm excited by it. The open sourcing strategy is not new to Meta. We have had a history of doing this, including the PyTorch ecosystem, including many of the models that we gave, whether it's Detectron 2, Segment Anything, some of the things that you just saw, Caitlin, touch on in terms of experiences that we have enabled in Quest and in smart glasses. So Llama is another step in that direction of bringing along all of you, all of the entire community to actually make innovation go faster. Coming to Emu, one of the cool things about Emu is how fast people can actually use these models to generate something. Until Emu was out, the foundation of image models took multiple seconds or minutes, typically 30 to 40 seconds, or even 2 to 3 minutes to generate. It was not free, it was not accessible. What we did with Emu was bring down the best image generation within 5 seconds. What I mean by that is a simple query like this gives you an image that is high definition, real time, close to 5 seconds, and you can hammer at it and go wild. This is unlocking your imagination in a way that was not possible before. And these are just a few examples. We actually brought this to our agents in WhatsApp, in Instagram, in Messenger, so everybody in US can actually play with it and use it in conversations with your friends, in conversations with your loved ones and family and so on. So these are just a few examples. I'll let you play with it on your apps. And what is exciting about Emu and Llama is they're actually powering our agent ecosystem. And here what you see is a few products that we launched 2 weeks ago at Connect. I'll give you a quick glimpse of the simplest of things you can do with it. This is a sticker product. There are billions of stickers shared every month between people. Previously, all of the stickers were curated by designers. Now, each one of you, every one of you, as part of your conversations, can create whatever sticker you want using your imagination. It gets generated within 3 seconds, and you select it and you send it. This has unlocked an expression that was not possible before for billions of people. And this is used every day. And what is powering this is the foundation models. Here you see how we are able to take your photo that you probably cared about. In this case, it's Mark's dog, Beast. And you can actually do infinite combinations of expression. Previously, you would apply a style. This is like 5 or 10 styles that you train. Now, the AI understands the image and the style and can apply both seamlessly to generate various arts that was not possible before. So it's really giving you a power of expression that was not possible before because of the progress in generative AI. And these are all running within seconds. They don't take minutes. This is our Meta AI assistant that we actually brought to Ray-Ban glasses, Ray-Bans, and as well as Messenger, WhatsApp. So you can invoke this assistant in your one-on-one chats. You can invoke this assistant in your group chat. So the debates that you have with your friends and family will be settled well with the best assistant in the world. Not only does this assistant give you the answers in near real time, but it actually has access to real-time information. So if your query requires accessing the latest search engine, in this case, we partnered with Bing, it knows when to do it, it invokes the Bing API, brings the information back, synthesizes it based on the context, and gives you the latest information. This was not possible until now. because most of the foundation models, the large language models, including Llama, have hallucination and challenges with latest information. So with the access of search engine as well as ability to reason, you can put those two together to bring real-time information. We also brought Imagine, which is basically for people to invoke the EMU model as part of your group conversations or one-on-one to generate anything that you want. People are having fun. There are more than 20, 25 Imagine generations per person that are happening once we launch this product. So the people are going wild. And finally, I want to touch on one important vision that we believe in. Instead of thinking of one universal AI assistant or agent that is helping you, we believe in different AIs for different people. Again, getting back to the core of what is most personalized for you, what style you care about. Here you have agents that are helping you with cooking recipes, agents that are helping you with creative writing, agents that are helping you with entertainment and fun and expression, do it yourself, you name it. And we actually partner with some really fun people who are representing these agents for us and embodying them. Finally, the way we are doing all of this is in a very responsible way. The reason we haven't unlocked this for everyone from day one is we want to make sure that the models that we build, the product experiences that get unlocked using these models are done in a way where we are learning, where we are using fairness across the board. We are making sure it's working for everybody. We are increasing all of the positive impact it can have while mitigating any negative things, including ability to generate stickers that you don't want in your ecosystem, including imagining things that are probably not good to imagine and not acceptable for society, as well as having conversations with agents that are actually not productive and not connecting barriers and bringing you useful information. So it's really, really critical that while we build these models and we build the product experiences, we do it in a scalable, responsible way. And that is something that we have paid a lot of attention to. And that is also one of the reasons why we have open source and are actually getting a tremendous amount of input from the community. So overall, the journey is super exciting. I hope all of the models that we built and are making available to the entire ecosystem will help accelerate the innovation. I'm looking forward to how everybody is going to use this in products and what feedback we get and how we evolve together. Thank you so much.
Great, thanks. Thanks so much, CK and Mano. So we're just gonna move over and have a bit of a conversation now. Here, I'll just sit right over here. There's a story behind these chairs. Come see me after, but in case anyone finds a chair missing, don't rat us out. Yeah, so CK, Mano, welcome to ITC. This is like my worlds colliding. I've been part of this community for, since preschool, so for the past 30 years. And this is my home. I mean, you could see the amount of passion, and it's really been a labor of love. So welcome, and thanks for giving us a glimpse into where we're headed. But Mano, maybe I'll start with you. It seems like AI is all over the place. It's all the buzz, and it just seems like there's been a complete explosion of growth in AI. Why is that? Is it my imagination, or did things just happen overnight, or did the stars finally line up? What's made this all happen?
It's funny. It's been 2 decades since I got into AI, all the way from my undergrad, and I think we have had multiple inflection points, but this one seems much more closer to how people would use it in more practical ways than ever before that I have seen. And I think there are 3 or 4 recipes that are coming together. The first and most basic one is the evolution of the architecture, the transformer unit. This is the core machine learning building block that we're actually able to scale, that other models were not allowed to, that we were not able to scale before. So that is one. Second is something that we know, but it's a trajectory of amount of data we are able to squeeze in to train these models. So that trajectory has been more predictable. The third one is the compute we have been able to use to train. So give you an example, the deep learning revolution that happened end of 2012, when I was actually an intern at Meta, was using this model called AlexNet. Right now, that model can run at probably 50 to 60 FPS on the basic phone. In the last decade, that is the amount of progress we have been able to make in silicon, in the ability to train the models, and in the number of tasks these models are able to achieve. So to me, I think all of these coming together, and just more energy and investment as well as interest, and finally people using it. Even now, when I actually talk about the stickers product, which is one of the simplest of products you can think of, people think I'm actually looking up a sticker library and giving you the result, when I actually have to tell them that this is being generated by an AI in the background and you are giving whatever query you want. So to me, that's how I see it. So it's the data, compute, and ability to train these models using new architectures like the transformer units. That's kind of why we got this inflection.
Awesome. And CK, I mean, every time I see that podcast, I mean, I'm not sure from the audience if you've seen it before, but it really does give us a visualization of what's really possible now. I mean, I can't wait for this to come forward. But what are the signs that we're getting closer to our AR glasses vision?
Yeah, it's a great question. We already, of course, have the smart glasses out, but the full AR glasses that I described, we're going to take a little bit of time, and so we need to step our way towards them. And of course, the glasses with displays are what I'm working on now. But it is non-trivial, as I described. There's a lot that needs to happen to make good AR glasses. And so I think that, kind of to your point, Mano, you have to have custom silicon and silicon improvements. You have to have power improvements. You have to have sensor fusion. And then we got to pull it all together in a product that's, you know, something you want to wear for most of your day. And so I feel pretty good about the progress that we're making. But I do think it's important to step out into what we can deliver now, which is what's happening with the Smart Glasses group, which is my colleague Steve's group. I think they're doing a really good job with it.
Awesome. So you both talked a bit about vertical integration and hardware, software, co-design. You know, can you expand a little bit on that, maybe on why vertical integration is important for both AI and AR use cases? Maybe, Manu, you could start with AI.
Let's talk about the Llama model. You would not be able to train that model if it was not for vertical integration. So we actually built this cluster called RSC, Research Supercluster. 3 years ago was the plan. And in 10 months, we scrambled and built what is possibly now one of the largest compute clusters, definitely getting older. So we have new clusters coming up based on new hardware. So that is the first layer that is needed to be able to get the network, the memory bandwidth, and the storage used by these models in real time to train these models for weeks. And if you look at a 7 billion model, it's not going to be uber powerful, more generic. But if you look at a 70 billion model, it's very powerful, but it takes 2 months, 3 months, depending on the number of GPUs. The number of GPUs sometimes you use is in the order of 4,000 or 5,000. If you want to use 4,000 GPUs, they need to be connected through an interconnect. They cannot be connected through a typical Ethernet. That's one part. Then you need to think about the network, not only the network band, the memory bandwidth. What do you cache? What kind of storage do you need? How do you make sure that the gradients that the model is being used are propagating properly? And the WPS, the words per second that you're actually training on, is high enough so it doesn't become years to train this model. So it's like so many things coming together. So the hardware software co-design, the training modules and the machine learning modules, the distributed learning. And finally, when the model is ready, you would be like, okay, let's build a product. Then your journey of product begins, which is you have this pre-trained model that you need to align with various data use cases that you want. Then you align it, and then you realize you need to think about safety and responsibility. And I'm like, okay, let's think about safety and responsibility. Then you realize it's not running fast enough. Then you actually distill the model and make it specific to the hardware that you want to run, which is the inference hardware, sometimes similar, sometimes different. So it's this, and then there you use tools that are developed by everyone else. So all of these need to come together like an orchestra to get you that fascinating looking image in 5 seconds.
Yeah, it's not that different on device, because on device, we have to figure out what you can, so there's things you can only do on device, which is like the sensors, the compute, the displays, the graphics, all that together. But there's a lot that you could either do on device or off device. You could do it on the edge and servers or on device. And then we have to look at latency, we have to look at power, we have to look at battery life. And so you have what we're doing, and we have to do in the whole industry, is say, how much can we push to the device? Which means in co-design, you're really thinking, okay, I have to develop a whole new set of custom silicon that's job it is to take the data from the sensors and simplify it as much as possible so that the packet sizes are as small as possible, like the aggregate size of data is as small as possible. So I'm actually just, instead of taking all the, computer vision camera data and just sending that to the brain of the device, you're actually filtering that out, and all you end up with is a pointing angle, effectively, or in 3D space, and you send that to the silicon, the brain of the device. And so at every step, we're actually having to look at how to reduce latency, how to reduce any round trip over the network. And I think actually one of the things I'm most excited about is in the future co-design, where we're designing servers. Of course, we have a lot of them, but we're not really focused on what we need for AR glasses yet. And so we're going to have to actually put as much compute as possible, or the right compute, onto servers, which means we'll have to co-design even those servers. So it's going to be, it's kind of, you described it, it's kind of an iterative, it's like almost like a cycle where you get everything kind of the way you want it and good enough for a product, but then you realize, oh, it's too slow, or it's running too hot, or I can't do exactly what I want. And then you have to actually wrap everything together.
Yeah, no, it's great. And since we are in a test conference, myself and some of my team members who are in the audience, so we're actually responsible for doing the test integration, adding test features into these products. And what you both described are completely different use cases. I mean, we have bookend views from data center, high performance compute applications, down to these tiny chips in this really challenging form factor with that thermal envelope that we have to not only design to, but like I said before, if you're designing it, you have to have a way to be able to test and manufacture it at a large scale, because if you don't have a high quality, reliable device, I mean, I don't have to educate the audience here, but that you're going to completely obliterate your user experience. So everything that this community is offering, we'll take it and we'll put it to good use, because we pretty much need everything to go into these products that we're building. Yeah. So again, we saw the video, we do that, but and we sense the passion in your voices. But personally, like, what are you guys most excited about for these glasses? I mean, I'm just gonna throw this out. Like I've worn glasses for as long as I can remember. So just knowing that I can get some more use out of these glasses. There's another, we ran into this when I was getting mic'd up. Like, there's something else that I want the community to help design for, which is deeper pockets in women's clothing. But my phones keep getting bigger and bigger, and I have no pockets to put them in. So I'd rather just use my glasses. So that's kind of what
I don't know if we can help with the pockets, but yeah, no, I think what I'm most excited about is unplanned, unintended use cases that our users actually come up with. Like, it's so exciting because you put something out there and people don't always use it the way you think. Now, generally they use the key use cases the way you think, but when we did VR and COVID came with Quest 2, everybody started working out in it. And we were like, what is this? And so all these fitness apps became really popular. That was not planned. And, we adapted, we had facial interfaces like that were, silicon and all this stuff, but we adapted and then integrated that into our products. And with the smart glasses, the thing was so surprising to us is actually people love taking phone calls and listening to music on their smart glasses. The audio applications and, the video and the camera is awesome, but the audio applications ended up being the thing that was the most retentive, that people were most excited about. And so, like, there's always, you put something out, it's just like, when the iPhone came out, you never thought about like being able to call a car from anywhere and to take you to anywhere. Uber didn't exist. But because you are combining, always connectivity with GPS, basically, that enabled, I want to think it was like 7 years later, 5 years later, an app that nobody had envisioned in the beginning. And so this is the thing that I'm most excited about. It's like you start to bring these things together and what can people do with it? And there's always some surprises.
Yeah, and the intersection of bringing Meta AI to smart glasses is another one that I don't believe was planned before. So it was the generative AI curve intersecting with the smart glasses. And suddenly we were like, wait, you can invoke the assistant. It understands the context, knows you, and immediately gives you an answer to you without you actually disrupting anything that you're doing. You're on the go, you're minding your business as usual, while you have a pocket assistant that is able to bring world's information within your fingertips in a seamless way. So this was something that was not planned because we didn't know we could build a Meta AI assistant with this quality and access to world's information at the same time as the hardware, and we did, and we're launching it. So that's pretty awesome.
Nice. And so CK, you talked a lot about VR and AR. Do they coexist, or is one gonna outlive the other?
Yeah, this is interesting. So mixed reality, you could think of it as mixed reality is kind of on both. So applications where you need to see the real world, you either have reprojection through VR, you're seeing it in AR. But there's a lot of applications that don't make sense for AR. Like if I'm gonna go to another planet and play Beat Saber or something, I don't really necessarily want to do that in my AR glasses. And if I want context while I'm driving down the street, I definitely don't want to use VR for that. So like, I think that you've got this sense of the technologies we're developing inform the other, and we can learn a lot. Like MR has informed a lot about how we think about AR. So MR on virtual reality has informed a lot about how we think about AR and overlays essentially and world locking. But I don't think they converge. And that was a big question a while ago, but I don't think that they converge, but I do think that they inform each other.
Yeah. All right, so everybody's probably got, I mean, show of hands, I mean, who's got WhatsApp, Facebook, Instagram on your phones? Okay.
They're shy, but they all have it.
Okay, it's private, I understand, but yeah, so we are known as a social media company. We have all of these social technologies. So, Manu, I'm going to throw this one at you. We're really in the business of connecting people. And so what are the unique challenges as well as the opportunities that presents to us? Because it's kind of in our DNA.
Yeah, this is a really good one because I think it's at the heart of both our company, but also at the heart of how we think about technology as an enabler or a substitute for other human connection, right? So including AI. The way I have wrapped my head around is you could try to train yourself to run faster and faster and faster, but if the other person is going to get in a car, they're going to outrun you no matter what. So my hope is every time we keep pushing these frontiers of the technology, whatever is possible, they become enablers for you or anyone else to do things that was not just possible before. So imagine having that debate where you're increasing your knowledge as a group. Imagine planning that trip that always becomes a P1 or P2 priority because everybody is busy. Those all become more a reality now because you have these agents that understand and enable you and empower you to make it more fun, more engaging, more expressive, and bring you information in a proactive manner in the context of groups that I don't think was possible before. So to me, I hope that whenever we're pushing on these technologies, whether it's this hardware or AI, we always ask, how is it helping user get more options and enabling them to do things faster, better than substituting something. So this has been my driving force. I think this has been at the heart of how we think about many of the things that we are trying to offer.
Yeah, and I think maybe just to add to it, I mean, we are also building consumer devices. So it's our path. We're obviously innovating. There's so much complexities in what we're doing, but we're really not doing it just, papers are great, patents are great, but we really are trying to scale this, make it accessible to as many people as possible, because it is for social presence, social connectivity, and that doesn't happen if we just do one and we're done. So yeah. That's awesome. All right, so we are building for the future. So CK, what does that look like
Yeah.
for your day?
Well, it's tough to come to a room like this and say, what is the future going to be like? Because we don't know. Like, I can guess, but I'm probably going to be wrong about half of it. And so like, it's kind of an interesting, building for the future is challenging, especially when you're speaking externally, because you're like, this is where I think things are going to go. But certainly many of those things aren't going to go the way that I think, because something's going to happen that we can't anticipate. Like maybe AI will get so good at denoising sensing that we don't have as big of a problem as I think we're going to have with like the sensor size. Maybe people will decide, they want AR glasses, but the features they want are a little different than what we think. And so, for a technologist who has to think about the future, the best thing we can do is really ship and see what people want to use and then adapt to that. And it's like a pretty big feedback loop. I mean, you see that we've been doing VR for 7 years, and some companies are just coming out with VR now. But what that gives us is a huge amount of information about people, what they want to use, what features they care about. Last year we came out with the Quest Pro. It had color pass-through, but we didn't put as much focus on color pass-through as we did with the Quest 3, because we realized, oh my gosh, like this is like actually fundamental to good VR. And so this is an iterative process that we have to use. And I think living in the future is like, you have to be excited about the future and the use cases and the things that don't exist yet, but also be very cognizant that like you could be wrong, and you could even be wrong about some of the fundamentals, and ship anyway. So it's like a weird, it's a weird dichotomy.
Absolutely. Maybe just keying off of that a little bit more. Why do you think it's important to factor diversity in building all of these technologies?
Yeah, I can start with that. In wearable technologies, things that are on our bodies, things that are kind of what I would call almost like intimate technologies, like smartwatches, VR, AR. It's different than a laptop, right? You could build one laptop and like pretty much everybody can use it. And if your team's all the same, like it's probably not a deal breaker, right? The first time we really started seeing this is, Apple made the Apple Watch, the original Apple Watch, and internally they didn't have anybody with tattoos on the team, basically. And they started testing it and they realized it didn't work with tattoos, right? And so you've got this group of people who like, I used to work there, awesome people, but you don't have the kind of diversity on something really simple as tattoos. And so most of, I think it's like 40% of women in the US have tattoos, right? And so like, this is kind of a fundamental thing. Or like if your VR headset doesn't fit people with smaller heads or larger heads, like, or their interpupillary distance isn't covered, then they can't use your product. And so or if their hairstyle can't be, if you can't adapt to the straps to their hairstyle, they can't use the product. And so I just feel like in addition to like, you could argue against the moral argument, which I believe that diversity is important. If you don't have diversity in your team and you end up testing your product at the end and user testing or whatever, it's too late. Things are moving too fast. You actually need that upstream. You need, and I'm talking about, clearly men, women, but also skin color, body sizes, hairstyles, attire, tattoos. Like this is actually kind of a big. I'm casting a wide net when I say diversity, because if you don't get it right, your products won't be good.
That's great. So there's a lot of talk about democratizing AI and all this disruptive tech. We're asking the community to do a lot for us, but what are we giving back, and what are we unleashing and enabling people to do? Manu, do you want to?
Yeah, open sourcing Llama was a much bigger movement than we anticipated, honestly. When we first open sourced it, we thought of it as, okay, this will allow us to make faster progress and allow us to build a safer model for everybody. It turns out that it unlocked possibilities for many startups, many entrepreneurs, many researchers in universities that couldn't build such a model, such a high quality model that you then piggyback off of, which is becoming almost like a platform now, where these language models are invoking tools, they're invoking plugins, they're invoking the search plugin, and so on and so forth, right? So to me, one of the fascinating things is there is a saying in machine learning, which is you don't want to overfit the model, but if you overfit to the world, it's actually okay. So To me, if Llama or these foundation models work for everyone, going back to your question on making it work for everyone and thinking about diversity, it's actually the goal. Otherwise, making it work is equivalent to making it work for everyone, in my opinion. Otherwise, you're not making it work. Like, it's not working for everyone, right? So to me, that's really the driving force of what we are trying to give, which is we could have open sourced the smaller model and keep the bigger model for ourselves. That would mean the capabilities that the bigger models, larger models unlock is only accessible to one part of the company or one company, which is not the vision that we want to go after. This is not how you accelerate progress. Now that everybody has access to this model, they can play with it, make it better. We can think about hardware, vertical integration. We can think about hardware, software core design. We can think about what are the limitations of these models. What additional work do we need to do to make it work for different countries, different use cases that we haven't envisioned and we don't have the bandwidth to envision. So this is something that has been at the core of how I thought of model development in AI and our journey to making it work for everyone.
So just shifting gears a little bit. So there's so much co-development going on. And I've just been at Meta for about 3.5 years, and in that period of time, there's been a lot of activity and NTIs and so on. What can you share about the org strategies and the engineering mindset and behaviors that are essential for bringing this type of innovation to our products? And maybe Sikhil.
NTIs for us means new technology introduction. I think that's the acronym. And so like we think about NPI, which is products, but we also have to get technology readiness before it can go into products. So I think that's what you're talking about. Well, agility. We have to move so fast because like every time something changes, you have to be able to adapt. And I think that's probably organizationally, like you have to find people who are comfortable with that. Most of us aren't. Like I'm not often comfortable with that, but you need to find people who can really pivot quickly to be in this space.
Yeah, and maybe along that, just passing this back to our partners here. I think one of the challenges that we have in our space is, a lot of the test challenges that we're looking at and how we're introducing them, they're not really completely new. We're not introducing new techniques or anything like that, but it's just the ability to iterate, adapt to these changing requirements, embracing the new technology as it comes forward. We work heavily with a lot of our ASIC partners, and they're experts in this field, but they're really operating under different priorities. They want to improve their margins. They want to reduce test time. They want to come up with a lot of these strategies. So the features that they put in to achieve these end goals end up sort of competing with our ultimate product priorities, which is like power and schedule and this iteration time. So I think going forward, we really need to see that agility in the ecosystem as well, and the kind of a convergence of all of the different technologies coming together. Mano, do you have anything to add there?
The closest example that I have come to, one of the hypotheses we have had is how can these models make you more efficient in your development cycle? And we actually found a very sweet spot of multiple kinds of profiles, like whether it's engineers or cross-functional teams in legal and policy and HR and so on, actually leveraging these models to become close to 3 to 5% more efficient in what they do, whether it's accessing information quickly or expressing their test in a new, different way by asking these models, which have actually looked at various use cases from across the board. So it's been an interesting journey there, where our initial hypothesis was this could be useful, to now tens of thousands of engineers and various profiles in the company using many of these agents to help with their day-to-day tasks in becoming more effective. So that's an example that resonates a lot with me, and I think we are in the beginning of that journey.
Awesome. All right, so maybe this is going to be one of our last questions, but so should we be afraid? I mean, the interesting notion is that a lot of people say that technology is attributed to antisocial behavior. And coming back to the reason why we're doing this in a social media company is we're going against that. So maybe two factors is like, is that true? Like, do we really think this technology is going to actually help us connect better? And then how do we really address the genuine fears that a lot of people have that all this technology is going to make the people no longer relevant? So take it whichever way you want.
Easy question.
Okay.
I think some of these questions should be answered from a personal experience point of view, because you are the best judge on how this is actually helping you. I remember when I moved to US, this was in 2007, I used to have to pay, I don't know exactly what the amount was, anywhere between like 10 to 12 cents per minute to talk to my parents. And I would count, because I was a grad student, okay, I have 3 minutes. After 3 minutes, I need to cut the call. Today, I do hours of video calls to make sure my kids are seeing their grandparents. This is the simplest of examples that you can think of. Today, I'm connected to my alma mater, whether it's Georgia Tech, whether it's IIIT Hyderabad, whether it's to give a new talk in a new city, or to meet a friend when I'm traveling for work or for personal reasons, with ease. Some of these are connecting tools that we are able to build. Some of these are hardware or technologies that we are able to build. I am not an artist, nowhere close to one. But when I generate one of these stickers using some crazy awesome expression that is unique to me, it makes me feel better. It makes me feel like I can express myself compared to another artist doing a great job and I'm selecting one of it. So to me, these are like personal examples of how you kind of blend the technological innovation to real world use cases that make people happier, more connected, more fun. And actually, one of the beautiful things in the last 2 weeks after we launched our assistant is more than half of the invocations of the assistant happens in a group setting. And this is something unique that we can do as a company, where people are asking for information and help in the context of group. The assistant gives information, and everybody in the group has that access. Instead of me going to an assistant, getting away from my social circle, having a conversation with an agent, and getting in information, which is you're now making me choose spending time with my friends or family or whatever it is that I'm doing to another part of the ecosystem, rather than trying to come to where you are actually spending time. So these are just examples, and how you design products matters a lot, where you ask, how do we make sure people are able to use this to connect better, to actually remove these physical barriers. And the Lex Fridman video, it's not the technology that makes me happy. It's the fact that the physical distance was taken away and you're able to bring them together closer, right? It's a meta perspective, but I think from a technological perspective, that's what I care about and I would want us to think about a lot.
Awesome.
All right. Well, thank you, Caitlin, Mano. Thank you so much.
Thank you for having us. Yeah.
Yeah.
Thanks a
really
lot.
appreciate it. All right.